Hi and welcome to week 9 of the 30-week Leaving Cert Ordinary Level Countdown from TheMathsTutor.ie. As always, there is access for the full members on the website, so for the full 30-week countdown. And for those of you who are not full members, as always, we're picking out a couple of the videos that are there for our full members to let you see some of the material we have. So the two videos from this week, so this week we're going to be looking at more differentiation, and the two videos this week, the first one there is on max and min problems. So we're going to be looking at applications of differentiation and local maximums and local minimums. So that's the first video on local max and local min, max and min problems. And the second video is the 2015 paper 1 question 8. So this is just an example that looks at using applications of differentiation or calculus. Okay, so today then we're going to continue looking at our differentiation. Just to point out to you, we talked about it last week, but this is page 21 of our tables, and we were using this rule here, that anything to the power of 0 becomes 1. So it's just to point out that that's on page 21 of our tables. So when we differentiate and we bring our power to the front, if we're left with an x to the 0, it becomes 1. It's from page 21 of your tables, just to know where that formula is coming from. So we're going to be using that again today, because we're going to be looking at questions where we're going to have to use differentiation to solve, and one of the things we will be doing will be bringing the powers to the front as multiplies and reducing the powers as by 1, which means that we will end up with x to the 0s again. So to get started on today's work then, the first question we're going to look at here is 2019 paper 1 question 7, and just the part D of this. So this says a camogie goalkeeper on a level pitch hit a ball straight up into the air. The path that the ball travelled can be modelled by the function f of t goes to minus 4t squared plus 16t plus 1, where t is an element of or, so it's a real number, where t is the time in seconds from when the ball is hit, and f of t was the height of the ball in metres above the pitch. The ball landed on the ground without being hit again. So the part that we're looking at is the part of this question that is involved with calculus and how I know that I'm going to be using my calculus or my differentiation to solve these questions. So here it says in D part 1, find f dashed of t. So we see this little dashed here of t, and it tells me the derivative of. So that tells me that I'm going to be using my dy dx or my calculus or my differentiation, lots of different names for it like we saw in week 8 last week. So we're going to be using our differentiation. So to find f dashed of t, we know that we have to bring the power to the front. So the power we're looking at, what powers does this have? Now this time it's in terms of t. Last week when we were looking at them, they were in terms of x, but we said we can have any variable. So this is in terms of t. So I see we have a t squared here. We have a t that doesn't have any power, so that's the same as being t to the power of 1. And then we have a plus 1 on its own, which is a constant. And we said anytime we differentiate a constant, we're always going to get 0. So I know that that part is going to become 0. But to differentiate or find f dashed of t, we're going to bring the power to the front. So minus 2 multiplied by 4t squared and reduce the power by 1. So minus 1. Plus, bring the power to the front, so I've written a 1, so that's my power of 1, multiplied by 16t to the 1 minus 1, and the plus 1 is going to become a 0 when we differentiate. So we're going to tidy that up. This is f dashed of t becomes, so minus 2 by 4 is minus 8, t to the 2 minus 1 is 1, plus 1 times 16 is 16, t to the 1 minus 1 is 0, and the 0 has just become 0. So this is where we get this t to the power of 0, x to the power of 0, anything to the power of 0, and we saw from page 21 of the tables there that that's the same as 1. So f dashed of t is equal to minus 8, t to the power of 1 we know is just t, plus 16 times 1, and that means that f dashed of t, my derivative of this function, is minus 8t plus 16. So that's the first part of part D, just says find the derivative. So I knew that I had to use calculus. I knew I had to differentiate because it said find f dashed of t and it said find the derivative of. In part 2, it says use your answer from D part 1 to find the speed of the ball. Okay, so speed here, when I see this, the speed of the ball, that's another way of telling me to use my calculus, use my differentiation, use dy dx, use f dashed of t. This is going to be f dashed of t. If I was given acceleration or asked about acceleration, that would be f2 dashed of t. So we would have to take our f dashed of t from up here and differentiate again. But here we're being asked about speed, so we're going to be using f dashed of t. So when it had been in the air for 4 seconds, so this is my time t, so t is equal to 4, and we're looking for what is f dashed of t at t equal to 4. So we're just going to take our f dashed of t, which was minus 8t plus 16, and we're going to sub in t equal to 4. So I'm going to say minus 8 times 4 plus 16, and when I put that into my calculator, I'm going to get a speed. And when I put that into my calculator, it actually gives me a minus 16. So I get minus 32 plus 16, but our speed is going to be 16 rather than minus 16. Speed is something that we describe as being scalar. So we'll just write this, speed is scalar. So that means that it doesn't have a direction, it only has a value or a magnitude, which means that it cannot be minus. So it cannot be minus. So when my calculator gives me that minus 16, I'm just going to take the 16 part and say my speed is 16. And it says give your answer in meters per second. So up here it's giving me my units, meters per second. So I'm going to say, well, this is 16 meters per second. So when t was 4, our speed using f dashed of t was 16 meters per second. The third part of that says use your answer from D part 1 to find the value of t for which the ball was descending and travelling at a speed of 8 meters per second. So again, I see my speed has been given to me here. So this is going to be my f dashed of t because it's speed. And this time I'm told it's descending. So that tells me that it's negative. So it's coming down. So our speed is still positive, 8 meters per second, but our f dashed of t, the change that we have here, is going to have a minus in front of it. So we're going to take our value for f dashed of t again from part 1. So that was minus 8t plus 16. And we're going to put it equal to minus because of the word descending and 8 because we were told that that was the speed. So minus 8t plus 16 is equal to minus 8, and we're going to solve for t. So we're going to subtract 16 from both sides of this equation, which gives me minus 8t is equal to minus 24. And we'll divide both sides of that by minus 8, and that gives us that t is equal to 3. So what units did t have? T was in seconds, so this is going to be at 3 seconds. So when time is 3, then the ball is going to be descending and have a speed of 8 meters per second. Okay, so that's the first example where we're using an application of differentiation, and the application that they asked us this time was about speed, and we know that speed is dy dx or f dashed of x or f dashed of t in this case, our differentiation. The next question we're going to look at is 2018 paper 1 question 5, which says the diagram on the right shows the graph of a quadratic function, and it says write down the coordinates of A, B and C. So this is fairly straightforward, where I'm just going to say how much do I go across, followed by how much do I go up or down. So with A, I don't go across at all, and then I go up 6 units, so that's going to be the 0.06. For B, I go across minus 2 and I don't go up or down, so that's 0. And for C, I go across 3 and I don't go up or down, so that's going to be 0 as well. So my points are A 0, 6, B minus 2, 0, and C 3, 0. It then says, show that the function can be written as this. Okay, to write it in a function, I'm going to be using these values that we have here. So our value for b and our value for c, we describe these as the roots. So the roots are where it crosses the x-axis. So we're going to be saying our roots in this case are going to be x is equal to -2 and x is equal to 3. So when we have the roots and we want to make the equation, we're going to turn those back into factors. So this is how we take our roots and write a quadratic from it. So the factor that gives me this root, this is where we solved that bracket factor equal to 0. So that's going to be x plus 2 is that factor. And this one here is going to be the factor of x minus 3. So they're the two factors that I get from those roots. So we would normally, if we have a quadratic and we're solving, we take our factors and we put them equal to 0 and we get our roots, or where it crosses the x-axis. This time we're working backwards. We have our roots and we turn them into our factors. So we're going to multiply those factors. So we do that by splitting the first bracket, which gives me an x and a plus 2. And we multiply both of those things by the second bracket, which is an x minus 3. So when I multiply this out, I get x squared minus 3x plus 2x minus 6. And I tidy that up to get x squared minus x minus 6. Now, this isn't the function that we've been asked to show because I can see that we have a positive x squared here. So a positive x squared here, I know that this would be U-shaped. And the graph that we're given up here is N-shaped. So what we're going to do is we're going to have to take another value. So we're going to say, okay, if y is equal to this, we're going to put another letter in front of it. And we're going to take just the letter A for sake. You can take any letter that you want. So we're going to say y is equal to A times what we've gotten from multiplying out those roots. Because there's loads and loads of different quadratics that could go through those roots. But we want the one specifically that is going to have an N shape. And we also want the one that goes through the point A. So at the point A, I can see from this point here that when x is equal to 0, y is equal to 6. So I'm going to sub in those values. So I'm going to say, okay, so 6 is equal to A times 0 squared minus 0 minus 6. And when I put that into my calculator, I get minus 6 multiplied by the A that's there. I divide both sides by what's touching the A, and I get A is equal to minus 1. So now that we've solved for A, we're going to sub that in for our y. Y is equal to minus 1 times x squared minus x minus 6. So we sub that into our equation that we had here of y equals. So we say y is equal to, we've replaced a with minus 1 and we multiply out that bracket, minus x squared plus x plus 6. And that's what it asked me to show up here. So minus x squared plus x plus 6 minus x squared plus x plus 6. So now we've shown that our function can be written in that form. Now we're going to go and look at our calculus. So we've worked out what the function is, and now it says show using calculus that the maximum point of f of x is. So remember, one of our videos that we're showing you there is all about maximum and minimums, because when we're dealing with these local max or local min points or turning points, this is where we're going to be saying f dashed of x or dy dx is going to be equal to 0 at a maximum point. Okay, so I know that dy dx or f dashed of x is going to be equal to 0. So that means I'm going to have to find f dashed of x. Well, f of x we've shown is equal to minus x squared plus x plus 6. And now we're going to have to do dy dx or f dashed of x or differentiate or use calculus, all the different ways that they can ask us. So again, I'm going to put in a power of 1 on that x just to make it a little bit easier for myself. So f dashed of x is equal to minus, bring the power to the front, so 2 times x to the 2 and subtract 1 from the power, plus bring the power to the front, 1 times x to the 1 minus 1, and the 6 is going to become a 0, and that gives me minus 2x to the 1, which we know is just x, plus 1 times x to the 0, which we know is 1. So I get minus 2x plus 1 is f dashed of x. So that's the first part that I have to do. I've used my calculus, and now I'm going to use the fact that this is equal to 0 at a maximum point. So I'm going to take my f dashed of x and put it equal to 0. So I'm going to subtract 1 from both sides, and then I'll divide both sides by minus 2, and that gives me x is equal to a half. In this case, they've written it as a decimal, so I'm going to change it to a decimal. So x is equal to 0.5. That's the first part done. I found the x, but now I need to find the value of y. So it tells me here that y is equal to 6.25. So remember, y is the same thing as f of x. So I'm just going to sub in to my f of x, or my y. So y is equal to minus 0.5 to be squared, plus 0.5 plus 6, and when I put that into my calculator, I get 6.25. So I'm going to say my maximum point is x is 0.5 and y is 6.25. So that was my second application. So in our first one, we saw we were using speed, and that was telling us to do dy dx or calculus or f dashed of x. In our second one, we saw that it was asking us about a maximum point, and we were using calculus to do that. The next question that we're going to look at then is 2018 paper 1, question 8, part E. And this question says the amount in appropriate units of a certain medicinal drug in the bloodstream T hours after it has been taken can be estimated by this function. So C of t is equal to minus t cubed plus 4.5t squared plus 54t, where t is between 0 and 9 and t is a real number. So the part E that we're looking at says use the drug amount function C of t is equal to minus t cubed plus 4.5t squared plus 54t to find in terms of t the rate at which the drug amount is changing after t hours. So a couple of things that we need to note there. In terms of t, so my answer will have t's in it, and this time it says the rate at which something is changing. So this is another way we have of saying this is use dy dx, this is use differentiation, this is use calculus, this is use f dashed of x. So there's lots and lots of different ways we have of telling us to use calculus, and we need to get good at spotting them. And this is the third different way that we have here now in this lesson. So we're going to see the rate at which the drug is changing. So that is telling me to find C dash of t. So we're going to differentiate with respect to t. So again, we're going to pick out our powers. We have a cube, we have a square, and I'm going to put a 1 on this t because there isn't one on it yet. And we're going to bring the power to the front and reduce the power by 1. So when the power comes to the front, it becomes a multiply, and we reduce the power by 1. And when we tidy that up, I get minus 3t squared plus 9t, and that's t to the 1 is the same as t, plus 54t to the 0, which we know t to the 0 is 1, so 54 times 1 is just 54. 54. So the rate at which the drug amount is changing after t hours is now going to be minus 3t squared plus 9t plus 54. Part 2 of this Part E, part of 2018 question says use your answer to find the rate at which the drug amount is changing after 4 hours. So this was like with our 4 seconds in the camogie question. T is equal to 4 because this time T is in hours. So this is just sub in 4 everywhere we have a T. So minus 3 times 4 squared plus 9 times 4 plus 54, and when we put that into our calculator, we get 42. So our answer from our calculator is 42. And then we were told inappropriate units. So this is going to be units per hour. So our units are changing per hour. So units per hour. Part 3 says use your answer to part E, part 1 to find the maximum amount of the drug in the bloodstream over the first 9 hours. So the maximum amount. Now the first 9 hours was just that it told me 0 is less than or equal to t, less than or equal to 9. So it's just for all this time that we're looking at for this question. But when we have this maximum amount, remember C dashed of t is equal to 0. So when it's a maximum amount, my differentiation, my derivative, dy dx, f dashed of x, c dashed of t, however it's written, is going to be equal to 0. So we're going to write our c dashed of t again. So this was from part 1, and we had minus 3t squared plus 9t plus 54. And we're going to put this equal to 0. So when I put this equal to 0, I see that I have a quadratic. So remember, when my highest power is a square, I'm going to have a quadratic. And when I have a coefficient of a quadratic that has a leading minus in it here, I'm always going to use the minus b formula. So the minus b formula is here on page 20 of our tables. And we're just using this formula up here, the roots of the quadratic equation formula. It doesn't matter that it says x equals, we're going to be solving for t. So I'm going to write out my formula as t equals minus b plus minus the square root of b squared minus 4ac all over 2a. And we look at our quadratic here and we pick out. So a is the coefficient of t squared, so that's minus 3. B is the coefficient of t, so that's plus 9, and c is the independent term, the part that doesn't have any t in it, so that c is equal to 54. And we're going to sub that into our formula, so minus 9 plus or minus the square root of 9 squared minus 4 times minus 3 times 54, and that part's all under the square root, and all of that is the top line of my fraction that goes over 2 times minus 3. And when we sub that into our calculator, remember we sub in once with a plus and once with a minus, I get 2 answers that tell me t is minus 3 or t is equal to 6. So we've gotten 2 answers for t, but we were told up here at the very beginning of our question that t has to be between 0 and 9, and minus 3 isn't between 0 or 9, so that means that t is going to be equal to 6. So we're looking for the maximum amount of the drug. It's going to occur when t is equal to 6, but we need to find out how much of that do we have. So we're going to sub t equal to 6 into our c of t formula. So our c of t formula was the one that we had at the very beginning. So that was minus t cubed plus 5.4 t squared plus 54t. So when t is equal to 6, c of t is going to be equal to minus 6 cubed plus 4.5 times 6 squared plus 54 times 6. And when I sub that into my calculator, I'm going to get 270. And remember, this was C of t was units, so we were told they were appropriate units. Now, that's the amount of the drug. It's not the rate of change of the drug, which is why it goes back into the original equation, C of t, or our original formula for C of t, and we get units rather than units per hour. It's not a rate of change. We know that the maximum amount occurs when the rate of change, or dy dx, or C dash of t is equal to 0. And once we find that value of t, we sub that in to find what is the maximum amount of units. So the maximum amount of units are 270 units, and it occurs when t is equal to 6. So max amount is equal to 270 units. That's the final answer for that part of the question. Okay. And the last part of this question then says, use your answer to E part 1 to show that the drug amount in the bloodstream is decreasing 7 hours after the drug has been taken. So we saw this with our Komogi as well. So when it's decreasing, we know that it's going to be negative. And we want to show this 7 hours after, so that's when t is equal to 7. So what we're going to be doing here is we're going to be using our C dash of t, because that's our rate of change. So we're looking at the amount of drug is decreasing. So we're looking at the change in the amount of drug that's there. So our C dash of t was minus 3t squared plus 9t plus 54. So when t is equal to 7, our rate of change is minus 3 times 7 squared plus 9 times 7 plus 54. And when we put that into our calculator, we're going to get minus 30, and that's going to be units per hour, because it's the rate of change. And it was telling me to use that here, the answer from part E, part 1. So this was the rate of change, the amount of drug in the bloodstream. The fact that we get this minus here is going to be explaining that we have a decrease in the amount of drug. So since the answer is negative, or minus, whichever way we want to call it, this shows it is decreasing. So we can see that the amount of drug is decreasing at that time. So that was a third way of saying use calculus by saying find the rate of change. And the last question we're going to look at, this is 2016 paper 1 question 8. So this says, Kieran has 21 metres of fencing. He wants to enclose a vegetable garden in a rectangular shape as shown. By writing an expression for the perimeter of the vegetable garden in terms of x and y, show that y is equal to this. Okay, so our clue here is our perimeter. So our perimeter, remember, we start at one corner, we work all the way around the outside until we get back to that corner, and we just keep adding all the distances. So I'm going to say x plus y plus x plus y, and he has 21 metres of fencing, so the perimeter is going to equal 21. And it's a rectangle, so remember opposite sides are going to be equal in length, and that's where the second x and y are coming from. So putting like with like gives me 2x plus 2y is equal to 21, and then I'm going to divide everything by 2. So I'm dividing everything by 2 to get x plus y is equal to 10.5. Now, why am I dividing by 2? Is because it says show that y equals, and I had a 2y. So I'm going to divide everything by 2. And now I'm going to subtract x from both sides. So I get 10.5 minus x is equal to y. So that's what it asked me to show. We're jumping down then to part D because this is where the calculus is going to come in, which says show that the area of the rectangle can be written as this. So I know that when I have an area of a rectangle, it's going to be length multiplied by width, which was x multiplied by y. But we also know that y can be written as 10.5 minus x. So y was equal to 10.5 minus x. So I'm going to substitute that in for this y here. So that's going to give me my area is equal to 10.5x minus x squared. Part 2 of part D says find dA dx. So this is our next way we see of saying use differentiation. Off you go and do your calculus, find dy dx, find f dashed of t. This time it's dA dx. So we're going to be differentiating the area that we had here with respect to x because we had x's over here. So again, I'm just going to pop a little 1 as a power on that x, and we're going to find dA dx. So we're bringing the power to the front as a multiply. So 1 multiplied by 10.5 x to the 1 minus 1 minus 2 multiplied by x to the 2 minus 1, and that gives me 10.5. X to the 0 is going to be 1, so that's just 10.5, minus 2x, 2 to the 1 is 1, so just minus 2x. So dA dx is equal to 10.5 minus 2x. And then it says, hence find the value of x, which will give the maximum area. So remember, when we see hence, we have to use our answer that we've just found. And when we see this maximum area, that's going to be dA dx is equal to 0. So we're going to take that formula 10.5 minus 2x and we're going to put it equal to 0. So I'm going to subtract 10.5 from both sides and then I'm going to divide both sides by minus 2 and I get x is equal to 5.25. And the last part says find the maximum area. Well, the area we had up here in part 1 was 10.5 x minus x squared. So I'm going to sub in my value for x and I'm going to say that area is equal to 10.5 times 5.25 minus 5.25 squared. And when I put that into my calculator, I'm going to get my area is equal to 27.56. And in this, at the very beginning, we were told that he had 21 meters. So we're just going to put in our units for these last two parts. So x is 5.25 meters at the maximum area, and the maximum area is 27.56 meters squared. Okay, so that was week 9 of our countdown. So again, all available on TheMathsTutor.ie, and that was on differentiation 2. So hopefully if you go and check out those other 2 videos, and hopefully between this lesson and those, that'll be useful to you. Thanks.